Right. So what I will do is that since we have all done the assignments and from what's just said, um, I just want us to compare the interpretation, the final interpretation. Let's know whether we are on the same page, or I assume that is settled for me to skip it and go to the next data modeling techniques. Where do you have your interpretation? This is, though we might not be working with the same data set, so but I would like to have your interpretation. What do you have there? The assignment. What did you arrive at? What did you arrive at? I just want to see your interpretation. Okay, so okay, now let's proceed. What I'm going to do is that I'll look into it later, but let me just go straight to the next, which is also the last data modeling technique. So far, so good. How many of the method we have treated? Remember, we started from which clustering? Started from clustering, right? K-mean clustering down to what? And then we are, so the main topic is still data what? Clustering, right? It is under clustering. We are looking at different techniques that are applied in clustering data. And remember, I told us that clustering means grouping, right? Segmenting your data points, which can also help in making decisions. So we are looking at the very last one, which is the DB scan. So let's start with the definition. What is the DB scan? So the DB scan represents density-based spatial clustering of application. Think, let me see if I can display it in a bigger screen, right? Or is it okay like this? Copy. All right, so like I was saying, the DB scan means density-based spatial clustering of application with noise. Is a clustering technique that identifies clusters based on the density of data point. So we can easily see the difference between the application of DB scan and K-mean and the hierarchical. Both of them, they were actually pointing to the distance, right? The basis for your clustering then was how one data point is away from what? The other. But in the case of DB scan, we are using density. That is one of the unique things about this. Now, if you look at the diagram we have here, I talk about noise. Noise are the one that does not have any data points around them. So it means that they cannot be clustered. They are totally off from the possible what? Clusters. That is what we have here. Now, just to explain further, we want to look at how it works. How does the DB scan works? Remember our usual way. What we are trying to do is to give us the theoretical knowledge, what the library or what the function will be doing at the background, because it's actually shorter and easier to perform in Python, but we need to know what Python must have done for us, or what Python will be doing to arrive at the possible data that will influence our conclusions. So how it works, number one, select a radius. So you have to select a radius, which is what abbreviated to or represented as EPS, and minimum number of points, which will be represented in the function as mean underscore sample. Then, secondly, within a scatter plot, label each point as one of the following. Within a scatter plot, label each point as one of the following. So we can have a point we refer to as the core point. We can also have a point we refer to as border point, and then noise point. So whenever you are deploying this clustering method or technique, we need to understand the points: core point, border point, noise point. Now, just to explain what we will be representing with each of these points. For the core point, has the minimum number of points within its radius in a dense region. For the border point, does not have the minimum number of points within its radius. That is, we are talking about the data points. We are still looking at clustering here now. We are talking about after you have identified a particular point as your core point, which is the one that uses the minimum number of points within its radius to attract order to it, while the border point does not have minimum what number of points. So in other words, is going to be going to be farther than the way the points in core points will be arranged. So it cannot easily. So this point might be far from the border point. Now, just to explain what I say, bots has at least one core point within its radius, which means on the outskirts of cluster. In the case of noise points, at what point we can refer to data points as noise points or try to cluster. That is the outlier, which means does not have a core point within its radius. So in other words, is an isolated point. So here we are looking at the density at which they can be clustered. The data point can be clustered. That is why we are establishing these three points. And these 3 points, they are the factor that Python will end up using to cluster. So just to add to, I say what DB scan allows for irregular shape clusters and can also identify outliers. So with that in mind, I want us to look at, so we are still looking at how it works. So all this falls under how it works. So let's know that as we deploy the Python library in clustering our data based on either what core point or what border what point or noise point, we should bear it at the back of our mind that there are steps that we follow. Now, here, step two. Step two here, select a point at random. We are still on how it works. Select the point at random and count the point within its radius. Now, I want us to use the diagram on the screen to interpret some of these points I'm talking about. Good. Look at the point one, the one that is inside the bigger cycle. The step one. The step one is the whole of this, how it works, all this explanation. Now, it's for you to understand that there are what points that you are going to use for the clustering. Now, once that step has been done or observed or put in place, then your step two, you start looking at selecting the random point. So what is happening here in my diagram is me trying to select different points. So I look at what the one at the center. You can see the numbers that are on the circumference of that what cycle. We have number 3, we have 2, we have 4, we have what 5. So which means that we are looking at the average of 2, 3, 4, 5 easily what cluster. Now there are some that are at the border. Like if you look at the explanation here, I said if it's greater than or equals to the minimum sample, then start a cluster. Label the point as a core point and mark the point within its radius as neighbor. We want to ask question. Okay.
The point we're looking at, one. Yeah.
Yeah, the one inside.
The one inside
the bigger cycle. Yes, then the other one that are marked 2, they are the one that they are radius. The radius. You understand? The minimum radius is what we are using to see whether they can be in that very one word cluster. Now, I was trying to explain the notes attached to it. I said if it is greater than or equals to the minimum sample, then starts a cluster, label the point as a core point. So we're looking at the scenario where it can be referred to as core point out of the 3 points as criteria for the clustering. If it's greater than or equals to the minimum. So now if you look at what the EPS is 0.75, for example, this is just like a graphical illustration so that we can get a picture of what we are going to be executing with Python library. So minimum sample here we have what 4. How did you calculate the 4? These are the ones on top of what? The bigger cycle. There are 4 of them. So it means that we can say that what? This is a core point. This is a core point. Because I said if it is greater than or equals to the minimum sample, then we can say what? A core point. And if you look at the first note, what is a core point? Core point is what? Core point has the minimum number of what? Points within its radius. Now, this is the diagram, the cycle there, the minimum number of what? The points within its radius. Here, in this case, now is equal to what? 4. So at what point I should know whether it is core point or it is border point or it is noise point is what we are trying to establish now. Because we are using density concepts. Now, for example, now if you come to step 3 here,
you see that what? There is difference now between the diagram you are having and this one. Step 3 is say what? Move to neighbor and count the points within each radius. So it's just moving. It's just moving. As you move, it will cluster different words, data points. When it was here, we have what are the neighbor here? The neighbor are those black. Okay, that means I have to go back to okay, provided I was thinking how you see it. So you can see this is a neighbor. These ones now, they are the ones that have the possibility of entering what? This cluster. So if I move this now, so this is the point we are moving now. If you move this one, they are at the border. This one is what? At the border of what? This particular what? Cluster. Because this particular cycle here is touching this one, but here is just at the edge. Now, when I move to the next one, you can see that what? Out of the two, let me take us back here. Here, this cycle is not touching any of these two, which are the neighbor, right? Now, here we move, which is step 3, telling us that move towards the neighbor. These two were the neighbor. Now we have moved the point, the core point. So which is the core point here now? This one here is the core point. So how are we using this core point to determine the cluster now? We are using the minimal sample what? Radius. So here, if it's greater than or equals to, like I said before, label it as what? Core point. So you will just keep moving. So that is this is exactly what Python will be doing. Be moving from one value to another, looking for whether it can be referred to as what? Core point, or noise point, or border point. So like I told us, this is logical. We're only trying to graphically explain what Python will be doing. Because we short code from a library, we will get this done. But then we need to know what the library will be doing. That is the essence of all this. So let's make sure that we are writing the notes, because when we get to the application, you will see all these being referred to. So you can see that when you move it again to another neighbor, you can see the way the appearance of it has also changed. So if it is less than, I use it now, we are looking at the scenario where it can be called what? Border. And look at the picture here. I want us to, I've explained this one, right? I've explained this. Now look at this one. So I will know the little or the slant differences. If it is less than minimum sample, but at least one of them is a core point, then you label it what? As what? Border. Yes, if it is less than minimum sample, but at least one of them is a core point, then you label it as what? Border point. So this is what? Border point. It's less than 4. But at least you have one core point. Which one is the core point here? The core point here is what? This. If there is no one inside it at all, you cannot call it what? Core point. But this particular...
There's no one inside.
You cannot call it now, because that is what this is saying now, that what? But at least one of them is what? Core what? Point, which is this. But it's less than what? The minimum what? Sample, compared to when we have those 4. The only sample we have here now is what? Just this and this. All right, now look at this one now. Move to a neighbor and count the points within each radius. If less than minimum sample and none of them is a core point, then it becomes what? Label it as what? Noise point. So all we need to know here is the criteria for arriving at core point, the criteria for arriving at noise point, and the criteria for arriving at the border point. That is just the background I'm trying to explain to us. So now look at this step 4 now. Move on to another neighbor and continue this process until all the points are labeled within the cluster. So that is just that is how you keep moving until all the points are labeled within the cluster. So that is what the library will keep doing as mechanism for performing the clustering under DB scan. So it just be moving, and then we will now calculate where it has at least one point. It will label it what? Core point, and keep moving like that. Now, the same movement is what I am trying to explain here. The same movement I'm trying to explain here, right, is moving differently and is generating different clusters as it moves. So the same thing here, the same moving. So move on to another random point and repeat the same step. The same thing, just for us to have more picture of it, move on to another random point and repeat the same steps. So it keeps moving to know whether core or what, border what, point. So that is what the library will be doing, keep moving. So move to another point. The same thing I'm explaining here. Like here now, as it's moving, what do you notice here? As you can see, no points within its radius. Therefore, it is called what? Noise what? Point. So here now, as you can also see, no points within its radius. This is also what? So wherever you see that there is no point within each what? Radius, you now know that what? That is noise point. Here, so everything we are talking about, you can see the picture of it here. Let me see if I can zoom out so that you can see. So you can see that here you have what? Two what? Clusters. Between this is what? This is 2. Then here is 4 what? Outliers. The one you are calling outlier now, they are the ones that are not associated, which we can easily classify as the what? The noise. You can see that what? They are totally what? Far. They are not in any of the cluster. So now let's summarize everything. So everything that I'm trying to explain since is what I have listed here, just for proper understanding. So here are some more detailed steps of how DB scan work. I think I should zoom this on. You can see that. So select a radius, which is the unit is measured in EPS, and a minimum number of points, which is called minimum sample. Within a scatter plot, select a point at random and count the point within each radius, which means if it is greater than or equals to the minimum sample, then start a cluster. Label the point as core point, and mark the point within the radius as neighbor. If it's less than the minimum sample, label the point as noise point and move to step 5. Move to another neighbor and count the point within each radius. So this is exactly a summary of what is happening or what will be happening. If it's greater than or equals to the minimum sample, label it as core point and mark its neighbor. To continue with another neighbor until all points are labeled within the cluster. Then move on to another random point and repeat the same step. So this is exactly what the library will be doing as a technique, which is the DB scan for data clustering. All right, so now let's start looking at how we are gradually getting to where we start implementing it in our Jupyter notebook. So you can use sklearn. Remember, we have used this Python library. So in other words, the DB scan is a function that is embedded in sklearn as a library. So you can use sklearn DB scan to perform DB scan clustering in Python. And the syntax is going to be, you are going to start by importing it. You are going to say from sklearn.cluster import DB scan. So that is the line of code we are going to run. Then we are going to save it as an object. We will say dbscan equals to the function, and then the function will calculate radius. Remember the theory aspect I was explaining at the minimum radius, right, of the data point. So that EPS is now an attribute which is setting the radius. And then you can say the minimum sample as another attribute, which means that you are setting to to 5 by default. Unlike what we're seeing there as 4. So when you set it to 5, you are directly saying that you must have minimum number of data points around the points you have identified in step 1 before such data points can be clustered. So if you look at what's explained here, the radius, so that EPS represents the radius or maximum distance between neighboring points, and the default is set on 0.5. So as we continue, you're going to see us, if we are not comfortable with the default, we can always change it. The minimum point in the radius needed to become a core point, including the point itself. By default, is also set on 5. So you may have noticed that there is no random state parameter, even though dbscan starts at a random point. This is because sklearn implementation of dbscan starts at the first point in the data set and move on from there. You could attempt to get different labels by shuffling the data from what I explained in the previous slide, where you move at a point, it becomes noise point because of the movement. Now, Here is, I think it's the same thing that we have there, but what I added here we have executed it. We have started transforming. We have passed in the data. So the first line has been explained in the previous slide. So in the second cell, we have fit a dbScan what model. That fit means what we are transforming with a function that has been stored in what dbScan what object. That is why you just simply call dbScan dbScan dot what fit. Then that data, remember that what is the name of the data you are working data set that you must have perfected. Then when you run it, it will output this, which means that what the number of clustered will have been determined with the total number of what data points, which is either minimum of what 5 or 4, or not even having one that will define the point. So here, this is where you are viewing the cluster assignment. So from what we are viewing here, from the notes I gave here, there are too many noise. From the explanation, when can we say we have what noise? When can we say we have noise? Point. When it's minus, right? So we have too many of them. So this noise means that there is no core points and there are no data what? Minimum data points around the points you are starting with. So the radius and the minimum sample to mainly see clustered instead. So this one is just an explanation. Let me see if I can zoom in so that you can see it. I think you want to write it down. Can you see better now? Okay, you have listened before. Okay. Okay, good. Okay, so now, so this is to give us a picture of the manual calculation you will have done, or the manual calculation the function will be doing. The library is just like the way I gave us when we were on the sklearn cluster. So the what we call seal-hot score. Seal-hot score. Seal-hot. So the following formula is used to calculate what? The seal-hot what? Score for each data point. Though all this theory does not actually concern, or where its matter is for you to know what the library will be doing. That is just, it's not as if you are going to be manually writing this function. It's just for you to know, oh, this is what the library, this is what the dbScan will be doing. So if you look at the diagram, we have the smallest average distance to what? To the point in a different what? Cluster. Subtracting from what? Average distance to other what? Points in the same what? Cluster. Divided by what? The maximum. The denominator normalize the differences. So the seal-hot score end up what? Between minus what? 1 and, that is -1 and what? +1. So when that is, punctated, this is what you get. So the data point fits well in the what? The cluster. To calculate the overall seal-hot score for a particular model, average of all the what? The seal-hot what? Score. Now let's move on. I want us to get to where we'll start inventing it. So here, the seal-hot score in Python. You can use sklearn in case you want to know where you're going to get the function from. You can use the sklearn seal-hot_score function to calculate the seal-hot score for the result of clustering model in Python. As you can see it demonstrated here. From sklearn dot matrix import cohort underscore score. Cohort underscore cohort, then the data set itself, which is this, the label, which show us what the actual number of what value in each word clusters. Then the metric, which is Euclidean. Remember this one. You remember this method where you're having a straight line from the last class. The technique I told us for measuring what? The distance when it's straight line, right? And then sample, we say what? Sample size, what? No. Then when you run it, so here I try explaining what each of these represents. This represents the data you fit the model on, which is required. This one represents the label your model generated. It's required also. Distance calculation used to calculate the cohort score. Optional. Size of the random subset of data used to calculate the score. Also what? Optional. So now let's go to let's go back to that
our notebook and start writing this code. Write the first one line. Yes, that's the place where we were working. Coming here, I've already written, see if I can see I have my code. Yes. Right, so I'll just run my, yeah.
Still complete. So now I want to fit So what we did here is just to import the library. Then here we have saved it as an object, and we are supplying the radius and the minimum sample, which I've explained. Like I said, by default, it's already at what, 5, and then this one is already at what, 0. So let's run. Have you written all this? So you have this. Now, if this particular data I'm working with, if it is not data, use another name, then I need to change this particular place to the name of my data. That is what I am transforming with the what? The DB scan. So these are the arrays of the cluster. From how look as if all of them are negative. Is that what we get? We are here to confirm yes. Let's just this to 7. This is that other data set that I actually used for that the slide. That other data set that I think I would advise also, since you have it, use that data set. Okay, you say you are using the 2 data set, have you?
Yeah.
What do you get when you use the other one?
The other one, while using 5, still everything, you still have -1, 1, 0.
The other one, have you?
Yeah.
And that is the one I use for the slide.
Yeah.
That is what I use because I don't intend to use
Shows
exactly.
entertainment.
Yes, that is what I use for this slide.
So changes the minimum sum, still quite noisy.
Okay, so let's just continue with the process with the data that. So the next now I want to know the number of clusters in the label that we just display now. So you can see it's 0. But run it on that other data now. I think we have about 2. So you can see exactly what the DB scan is doing because they are all noise. So that's why it has what? 0. So it could not form any group, could not form any cluster. Look at the next calculation. Now that we have found out the number of clusters, let's look at the seal holes. To run this under your data, because my own now, since this one is showing 0, I will not get any value. But run it on that one that you are getting to. So we abbreviated PS, the one representing the radius. So here you are bringing a function, you are looping. Now here you created a variable, you created a list an empty list. Here you define a range of that radius and minimum sample value to loop through. And then here you store it as an object using numpy and then a range function to specify some range as expected range for the data point. We have dot 1, then 2, and dot 1. So minimum sample value supply some random value. Now loop through the combination of the EPS and minimum sample using the for loop. Then remember, this is the object you created here. So what we are trying to achieve here is to loop. Remember, loop means what? Is going to over, let's say, iterate over the entire data to detect the number of what clusters that can be put together. That is what we are doing instead of the one we just did manually now. So we are giving the responsibility of determining the number of clusters to the loop function. That is what the whole of this code is doing. Now for minimal sample in minimal sample value, dbScan equals to, this is part of what we have done before. dbScan.transform, pass in your data name, then the label, dbScan what? Dot label. Then here, count the number of clusters excluding noise point label as -1. So number of clusters equals to len, means count. Set label to, if it is set label to 1, if it's what? -1, like we highlighted here. And then label to 0, label to 1 if it is 0. That is just like if statement, if conditional statement. That is what the whole of this line is doing. Then count the number of noise points, label as -1. So here you are storing that in this object. Then lists the number of label dot count if it is what? -1, as indicated here. Then here calculates the seal score. If number of cluster which must have been calculated, if it is greater than 1, then the seal score requires at least what? 2 cluster. It's still a conditional statement. seal equals to seal_score, then the data you are given, the label, which are the values you have, the for loop must have got to, passing them into it in order to give you the number of cluster you are looking for based on the condition you have set here and here. S, if you could not find anyone, S, none, does not exist. Then result.append. Append is a function for adding. So we are adding all the results. The radius, the minimal sample, the number of cluster, the noise, and this. Then put the result in a data frame. dbScan_results equals to PD data frame is a function we know from data analysis. Results column. Now here you are imputing, like I've explained here, put the results in a data frame. That data we are working with. All these results. So we are declaring the what? The parameters that we form the column. And that is what generated this. Here you display just what? The first 4 or 5 rather. So this is, you can see that there are some places where you have what? Not a number, just because of that condition where we said if it is not, you should declare it what? None. They are the ones that are translated to what? To this. But under this, you have the total number of what? Noise points. You also have the number of clustered to be this as well. And then you also have the total number of radius, the minimum sample, and all of that. So that is what the whole of this code is doing, using for loop, instead of you calculating them manually. the results you get here. You can see comparing the clusters, the number of what clusters you have here. So this is the result he came up with. Here, I could not compare based on the condition. Where we said that, if you look at the code carefully, there's a place where we said S0. Where is that place? Calculate the what? Calculate the, are you seeing this section very well? Calculate the what? The C-hot score. Now you use a conditional statement that if number of clusters, that is what is using. If number of cluster is greater than what? 1. Then the C-hot score require at least what? 2. So it must be greater than 1. Now, here you said what? You now created a C-hot object. And then this C-hot underscore score is now a function now that is receiving your data. And then also receiving the what? The array, which is what? The label. And then also determining the mode of measurement, or knowing the what? The density, which is what? The linear method that we explained the other time. Then of course, this one is just the sample what? Size. Now you now say S. In other words, by the time you supply this data, if the number of cluster is greater than 1, if this criteria is not met, then C-hot what? No. Now, let's go back to the result. Where you get a value here, the number of clusters is what? Is it less than 2? Look at what you get here. Then compare this one also. Then when you get here, where you have greater than what? This is what you get when you compare to what? Number of clusters greater than 3, greater than... Okay, sorry, I'm good. So you can see you have 0 here. Good. Here is greater than what? Greater than 1. That is why you're able to get this value. Here 2, you're able to get this value. Now here 0. What do you get? Nothing. So in conclusion, like as it's been indicated here, it's the one that determines what? That for comparing your clusters. And that is why the parameter we use in arriving at this value are due to what? The number of what? Clusters here.